This is the preview for the post-test semester 2. You guys just told me that this is a 2, and it does say plus? Okay, great. All right, so that would indicate a transformation. Which direction? All right, so horizontally, left 2. And vertically, up 3. Yes. Identify the amplitude and period in the trigonometric function. Amplitude is 3. Easy part. Oh, well, period is just 2 pi divided by the b value, which is 5, so 2 pi over 5. Amplitude, if that had been -3 there, guys, the amplitude still would have been positive. Yes. All right, error analysis. A student looked at the graph above and wrote that the period of the function is 2 pi. Describe and correct the student's error. Well, they looked at two cycles instead of one. Okay, the student or whatever. They looked at 2 cycles instead of 1. Yeah. Oops. Bless you. My pen is acting strange, so I'm having to hesitate, and I'm losing my smoothness of my wording. All right. Looked at 2 cycles instead of 1 cycle. The actual period is pi. Whatever. You can have your own wording. It doesn't have to be exactly what I wrote. As long as I got an explanation that is accurate. Yeah, the actual period is just pi. Number 4, at a town with a large convention center, the cost of a hotel room has increased. Yes? It is? Okay. Thank you. I think I changed a few things. All right. I had made a new one. I guess I should have used that. Oh, well, I didn't. At a town with a large convention center, the cost of a hotel room has increased 5.1% annually. If the average hotel room is still $37, all right, in 1990, and this growth continues, create a function that models the exponential growth of the room price starting in 1990. All right, exponential growth, remember, it was we looked at increase. It would be the initial amount, $37, times the increase, which would be 1 plus 0.051, which would be that decimal as a percentage, and then it'd be to the t. And that's all it asked for, right? And it didn't ask us for any dates or anything, so that was simply writing down the equation. Now, you may have simplified it as well. If you did, then you might have written, instead of this, y equals 37 times 1.051 to the t. No, I wouldn't mark off for it. Number 3, the depth of the ocean at a swim buoy reaches a maximum of 10 feet at 6 a.m. and a minimum of 4 feet at 4 feet. At, is this changed to? 6, oh, that has to be p.m. Does it say 6 feet at 6 a.m. and 4 feet at 6 p.m.? Or it needs to be p.m.? Okay, I had fixed mine apparently. All right, so write a trigonometric function that models the water depth. So do we have the right exact same numbers, guys, now at this point? Okay, so if it's a time over time, and time would be your x-axis, if you have a max at 6 a.m. and it says time 0 is 12 a.m., okay, so that's 0, 12 a.m., that would be 6 hours later, okay, and that would be your x value for the hours. And then your height, maximum height of 10 feet, would be your y value. Okay, then let's look at the rest. And a minimum, then you've got a min at 4 feet for the height, which would be the y value, and 6 p.m. How many hours have passed since midnight when you get to 6 p.m.? 18 hours. Okay, there's 12 hours to get to 12 noon, and then 6 more hours, 18 hours. So our the distance between here and here, 18 to 6, is 12 hours. But that's only the min to the max, or the max to the min. So that's only like half of the period. You with me? All right, so let's check out the heights first, and let's get that so we're not going to be putting these points in the wrong place. All right, so the max height was reached at 10 feet. So that's going to be our maximum value. Our minimum, 4, which is still above 0. Okay, so now what's the amplitude? Or first of all, let's find out what's the distance between these points. Would be 10 minus 4, which is 6 units. Cut that in half. Okay, and that would give you 3, amplitude of 3. All right, now where's your center line? Okay, 10 plus 4, 14 divided by 2, which is 7. Remember we did max plus min divided by 2. Okay, thank you. And so that's your center line at 7. Sorry, honey. All right, and then your min's 4. Okay, let's put in the min and the max. There's a max point at 10, 6. Now, wait a minute. We said that from 18 to 6 was 12 hours. That's only half the period if you're going from your min to the max. So that's the period. It's 24 hours. Okay, so let's go out to the end at 24. Half of that's 12. Half of that's 6. And then between 12 and 24 would be my 18 because the increments are 6. All right, so our max was at 610. And our min was at 18.4. So that means the graph was a sine wave because it has to go back to its midline. Then in the middle, it'll be at its midline, down to its min, back to its max, or midline, sorry, the end. This is a sine. Wait, guys. Addison, can you get up? All right, so you've got a K value, which can be at the front or the back of 7. Plus, then it went up and the amplitude was 3 times the sine of, and now we need a B value. The period's 24. Remember how we got B? It was equal to old period divided by the new period. So 2 pi divided by 24 simplified would be pi over 12 times x. All right, you comfortable with that? Obviously, it is on your final, mañana, post-final, post-preview, post-test. 6, identify the domain of a range of this function. You should know that's exponential growth with a vertical shift down 5. Okay, so that would be an asymptote down here. If you did stick in 0 for x, if you just wanted to check out the graph, it's not that you have to graph this to do it. You could look on your graphing calculator and see it. I might even have that. Actually, I've got issues with memory at the moment, so I'd rather not even open this up. Okay, I'm going to just close it. Sorry, it's just better. So I can get through this. I opened up Screencast-O-Matic. So anyway, if you put in 0 for x, you would get 1 minus 5, which is -4. So it crosses at -4 and it runs along the -5 as its asymptote, and then it increases. You don't have to even know where its y-intercept is to have known that the asymptote down here is at -5. All right, so the range, the domain's anything goes. So that's -infinity to infinity. But the range is restricted. It has an asymptote at -5, so you can't pass through it, -5 to infinity. Describe the end behavior of this. This is, yes, Scott? That's right. That's why I have a curved bracket. If you close it and make so it is non-inclusive. We have to have -5 on up. So what did you mean? Hard bracket means inclusive. Infinity's never got a hard bracket on it and it never has all year. All the infinities had soft brackets because you can't include infinity. You don't know really where it is, so you don't ever put a hard bracket on an infinity. Okay? Yes. You got a 1/4 x there. Okay, 3 times 1/4 to the x. Perfect. Thank you. I don't know why I didn't get this changed. I just must have opened up the wrong one. But anyway, 1/4 would indicate decay, right? Okay. Now you can go in and look at the graph, but if you put in 0, just to have an idea of what this looks like, if you put in 0 for x, you'd get 3 times 1. So that'd be 0, 3 would be an y-intercept, and it's coming down. Now it keeps on coming down and is approaching the x-axis. Okay, so on the left-hand side, it's approaching infinity. The graph's approaching infinity as x approaches negative infinity. And on the right-hand side, what's it approaching? The graph is trying to hit what? Yep, trying to hit 0 as x approaches infinity. But it doesn't ever get there. Okay. 8, sketch 2 cycles of y equals -2 sine x. Some of you need a reminder here that that -2 means to reflect. You want to note that? You've got an amplitude of 2 and a period that's normal period of 2 pi. Since our period's 2 pi and I have to do 2 cycles, I'm going to go 2 pi right in the middle there maybe, and then 4 pi at the end. I'm going to graph one cycle first, cut 2 pi in half is pi, cut that in half, pi over 2. My x scale is pi over 2. This, of course, is 0. 1 pi over 2, 2 pi over 2. Cut this area in half. That'd be 3 pi over 2. Now, if you want to get the rest of it labeled, we could have kept going. But right now, I think it's best we just go ahead and get a graph. We want to start at 0, 0. And then we need an amplitude numbers on here. So we have to go down to -2. And that's what happens first. Comes back to the center line. And then the max would have been at 2. We hit that at 3 pi over 2, and then we're back to our center line. So here's one cycle. Okay, I need to label these points. We got 0, 0, pi over 2, -2, pi 0, 3 pi over 2, 2, and 2 pi 0. After that, I'm just going to extend it by cutting this section in half. All of them. Cut them up. I've had increments of 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. 5 pi over 2 would be the next one. 6 pi over 2, which would be 3 pi. And then 7 pi over 2. And then you can just extend the wave. All right, any questions on that? Got our 5 key points, and we've graphed 2 cycles. Okay, number 9, the pressure P in millimeters of mercury against the walls of the blood vessels of a certain person is given by that equation. Is this the same equation? I want to make sure I'm not having anything different. Is it 80 minus 15 cosine 5 pi over 3t? Okay, is the time in seconds. If one cycle is equivalent to 1 heartbeat, then we need to know how long it takes to have 1 heartbeat occur. So, 1 cycle. What do I need to know then? If I need to know, okay, 1 cycle is equivalent to 1 heartbeat. 1 cycle is the period. Okay, I need to know the period. So I have to take 2 pi divided by the b value, which is 5 pi over 3. Bless you. Then I have to take and multiply by the reciprocal of 5 pi over 3, which is 3 over 5 pi. Now, the pi's would cancel out. We'd have 6/5. And if you want to write that as a decimal, you can divide 6 by 5 and get 1.2. Okay, now, that's the length of a period. It takes 1.2 seconds for 1 heartbeat. It said 1 cycle, right, is the equivalent of 1 heartbeat. If it takes 1.2 seconds for 1 heartbeat, how many, says, what is the person's pulse rate in beats per minute? Well, how many seconds are in a minute? Okay, so we need to know how many beats would happen if each beat takes 1.2 seconds, and you got 60 seconds. We need to take 60 and divide it by 1.2. I don't think this is going to be the best, most realistic heartbeat, but it's not very much. Doesn't it come out to like 45 or something, or 50? Yeah, it's 50. 50 beats per minute. Now, on the post-test final exam, you will get a little more reasonable answer. That's pretty slow, right? Yeah, it's a slow, athlete's resting heartbeat. Okay, simplify. I'm going to rewrite because I need to factor the third piece. You can put 2x minus 7 over 1. And then I have to change division to multiply by the reciprocal. Flip that fraction over. And then I'm going to factor the numerator, which is now the denominator. That would be 2x minus 7 times 2x plus 7. It's the difference of squares. Okay, then I can cancel out anything on top that matches something on the bottom. Top to bottom, these x plus 4's cancel. 2x minus 7 cancels with the factor of 2x minus 7 on the third term. And all I have left is x over, because these are really replaced with 1s. X times 1 is x. And on the bottom, I've got 1 times 2x plus 7. You cannot cancel out those x's. Leave it alone. These guys are married down here. Okay, 11. We need to add. This was one of our less strong concepts over the semester. We need to get a common denominator in order to add. So we need to multiply the first fraction by x minus 2. Okay, I'll need parentheses around my x plus 3. The second fraction, 6 over x minus 2, I need to multiply by the x plus 3, top and bottom. Okay, what I'm going to do now is distribute 4 over the x minus 2 to get 4x minus 8. I'm going to be adding my numerators. I'm going to distribute the 6 and get 6x plus 18. That's all over my common denominator of x plus 3 times x minus 2. The next step is to simplify the numerator. 4x plus 6x is 10x. Negative 8 plus 18 plus 10. Now, the denominator has two factors, x plus 3 and x minus 2. The numerator could be factored, but you could factor out a 10, but that wouldn't help you simplify anything, so we can just leave it at that. And it's not multiple choice, so I'm satisfied with that answer. Don't need you to FOIL out the denominator. Okay, 12, you deposit $1,000 in a savings account. Oh, this is the amount in the account. Remember, it started off with what you have in your account initially. So I must start with 1,000. For each year after, you plan to deposit 13% more than the previous year. Okay, so we're going to be adding on 13%. So 1 plus 0.13. And that would be to the time t. But it says how much money will you have deposited in all after 30 years? Well, we're going to, does it say 30? It says 20, doesn't it? Okay, pop in 20. And we just calculate away. I have done it before, but I've misplaced where I put my key. And I don't want to open up that calculator because I don't want to crash. So if y'all would please type that in. Oh, here I got it. 39,000, guys. Is that what you're getting? No. What do you? Okay, you got to tell me because actually I need to recalculate. 11,000. $523.09. I remember that's what second hour got. Yay. Okay. Pardon me? Yeah, exactly. That's why. I know exactly why. 13. Ryan tried to verify the following standard, but he didn't do it correctly. It's your job to describe the error and then complete the verification correctly. Well, it's hard to tell since he didn't show his details, right? He's trying to verify that what tan x equals if you simplified it, and I'm sorry that it says sex on there. That was a typo apparently, and that should be a C. Secant. Sorry about that. What? Yep, I'll have a fresh one for you. We're going to use a classroom set. Okay, so let's just talk about what it should have been. He started off correctly, didn't he? Those are truthful. Those are okay. Okay. Yep. All right, so the verification should have been, or what he meant by, and I understand what you're saying. This is not really a verification that each side is equivalent. That would be verifying an identity. This is actually simplifying an identity. Or not an identity, it's simplifying, period. Okay, but let's see what we got. So we would have done sine x over cosine x and shown that we would multiply by the reciprocal 1 over cosine x, which would be cosine x over 1. And then we would have been able to show that the cosines would cancel, and our final result would be the sine of x. So clearly, he has cosine squared on the bottom. So Ryan multiplied by 1 over cosine instead of its reciprocal. Okay. And then we showed the right answer. Okay, 14, error analysis. Again, describe and correct the error made, fix the mistake, and show the correct work on the right side. Well, let's see. Whoa, this person, okay. Whoever they are, they had the wrong, what? Common denominator. All right, so here's what it should be. 3 over x plus 4. That should get multiplied by x top and bottom. My pen is sticking. Hold on a second. Plus the 2 over x should be multiplied by x plus 4 top and bottom. He didn't even bother with that. He just counted the x with the x plus 4. He counted that as the same kind of x as the one over there. All right, so if we multiplied ours out, 3 times x plus, now I can distribute the 2x plus 8. That is all over x times x plus 4. And then we would simplify that to 5x plus 8 all over x times x plus 4. And there's no more simplifying to be done. You cannot cancel out the x's. 5x and 8 are married. So he had the wrong common denominator. I guess would be a fine enough description of his error. Solve. If you have a logarithm and you can't see anything to do, you have to rewrite it as an exponential. So the base is a 4. X plus 2 would equal base of 4 to the 6th power. Now that's a ginormous number. Well, not that ginormous. 4 to the 6th. Oh, please calculate that. So, geez, I did it again. I thought my calculator would work okay. But it's not going to be happy. I'll try. 4 to the 6th is 4,000 something. Okay, there you go. Yep, 4,096, and we got to subtract 2. So x is 4,094. Now, how do I solve this one? Well, there's 2 ways you could solve it. One is easy and one's a little bit harder, but doable. Got ideas? Yeah, these you could try to change the base and make a matching base. That's the easy way. And I actually jumped the gun and went ahead and did the hard way second hour, but I'm deciding to not do that right now because what if you couldn't see that? You don't really remember. Is that a plus one there? Thank you. I couldn't see it. What if you couldn't remember that or you didn't remember that? What other option would there be? Whenever you're trying to solve for an exponent, you can take the log of both sides. Okay, so I want you to know that that is an option. Because if these couldn't be put into common bases, say this was 25 right here, you'd have to do this. Okay? All right. Now, if they're in the same base now, you can drop the bases and set the exponents equal. Subtract 1, divide by 3, you'd get 2/3. Or, oh, wait a minute. What did I do? That's right. Okay. 2/3 would be the answer. If you did it this way, I can show quick. You would bring the exponent out front using your logarithm rules. So you'd have 3x plus 1 times the log of 3 equals the log of 27. You would divide by log 3. And then you could calculate this. This is just a number. And then after that, you would subtract 1 and divide by 3. Okay, so if you type log 27 divided by log 3, I'll even do it. You're going to need to close the parentheses if you're going to type it all at once. Okay. All right, and then you would subtract 1 and divide by 3, and we would have exactly 2/3, just like we did in the other part. 0.6 repeating. Got it? All right. 17. Consider this equation. What are the excluded values? Whatever the denominator would make the denominator be 0. This one factors to x minus 3 times x plus 3. Excuse me. All right, so x can't equal 3 or negative 3. Because either of those would make the denominator 0. Okay, each side has to decide between 2 job offers. Camco Industries has offered you a base salary of $35,000 with an annual $1,200 raise. Wallaby has offered you a base salary of $20,000 with an 8% annual raise. Okay, Camco's offer can be modeled by this equation, and Wallaby's offer modeled by this. Which is best, and explain your reasoning. Well, it's really going to depend on you and what your goals are with your working environment. I'm going to draw a pictorial quick. What's your starting pay on one of them? Let's see, $35,000, the other one's $25,000. And I'm only doing this, I didn't actually do this second hour because we were running slower. The one that is, well, I want to look at these thingies. Camco's offer is the one that's increasing on a steady basis, and it's just going up like that. Okay. Now, the other one, Wallaby's, is an exponential growth, and it does this. Okay. So if you go into your graphing calculator, you'd want to know when they're equal in pay. Okay. So check it out. Was it 1,200 or 12,000? 1,200x, wasn't it? Plus 35,000. And then the other company was an initial starting salary of $25,000, but you were getting an 8% a year, so that would be parentheses 1.08 to the X. Okay, now you're going to go to your graph, and you'll need to hit Zoom Fit. Uh-oh. I think my thing's going to freeze on me because, oh, nope, it didn't. Yay. That's way down here. Zoom Fit, enter. You'll be able to see what I just made for a sketch. All right, and then I would hit second, calculate, which is trace, intersect 5, enter, enter, and enter a third time. Now let's think about it. Here it says 7.26, about 7.3 years. I'm going to jot that down. Okay, when you're at a job though, when do you get a raise? Typically after a year, right? They evaluate you generally after a year, decide whether you're getting a raise or staying or whatever's going on. Or you might have some agreement with them already. So will you actually be making more money with Campco? Wait, which one's what? This is Wallaby. Oops. I'm just going to label them because it's going to help me think what I'm saying. The names are bugging me. I can explain it real easy until I try to put the names in there. All right, so after 7.3 years, Wallaby's going to be better. But wait a minute, you don't get that raise then. How long is it going to take? How many years later will the salary from Wallaby Corporation exceed Campco? It's really going to take you about 8 years, right? Now, I'm not going to get all nitpicky. If you write the 7.3, I at least know you can interpret it, but I want us to interpret it a little bit better in thinking, okay? So if you got to wait then, how long, now this thing right here, what you're going to write in this blank is really up to you and what you think, because I'm going to accept a reasonable explanation. But it's Wallaby that's better if you're going to stay for a really long time. But is it really going to be better to go to Wallaby even within 9 years? Because all this time, you've been making more money, right? That's a lot of years that you were making more money. You would really have to look at what have you actually made by now and count up all those years and think about where it really would be more beneficial to move to that Wallaby Corporation. All right, if you don't plan on staying more than 8 years, there's no point in taking the offer from Wallaby. So you guys get the idea? I'm not going to write down something verbatim for you to put there, okay? You understand that at some point, Wallaby's better, and that's if you plan to stay there long term. If you think you're going to switch jobs often, start off with Campco. Okay, you're going to watch the study habits of 5 calculus students from the same class. You're going to watch them, earning grades A to F. Determine whether the following situation calls for a survey, an observational study, or an experiment. Well, yep, observational study, because you're not doing anything to them and you're not giving them a questionnaire. So, okay, observational study. Oh, it's the same one. Is this the same as yours, guys? You want us to survey a sample of customers at a fast food chain restaurant on food quality? Describe how you administer the survey. Okay, so what should you do? Okay, give a survey to everybody once, or I would say maybe give a survey to every third person, okay, that walks in the door or that leaves. That you might want to know if they ate. You know, that might be good to get them before when they're coming out, not when they're going in. If there's their first time, third person coming out. It has to be some kind of random selection. In other words, if you went up to there and you went right at their peak time and all you did was survey every person walking out the door, you might not get a true sampling, because that might be their people that, or they find it their favorite place to go, you know, already. I don't know. You want to introduce as little bias as possible. All right, for a statistics project, a group of students decided to collect data in order to approximate the percent of students starting at a community college instead of a four-year university. They collected their data by interviewing students at Rock Valley College. Was this a good method of sampling? Okay, so explain a better method, sampling if you feel this method was inappropriate. No, Rock Valley is a community college, right? Well, they do have some four-year programs now. Is a two-year college, basically. So that's maybe your explanation of why it's not a good sampling method. Maybe you could, it says, wait, explain a better method. All right, might be better to randomly sample and this didn't say the percent of students starting at a community college where. Okay, maybe at a high school then. Say you want to know about that particular high school or at high schools in the area, maybe you could say. Randomly sample all students from high schools in the area. Okay, good enough. You got the idea. Theater company reviewed surveys of people's music preferences. Just trying to see if I even have the same problems in here. Okay. Yeah, you got 6 out of 31. All right. One survey reported that 200 questioned 45 preferred countries. A second survey noted that 67 out of 160 people surveyed liked hip hop. A third survey, I'm not thinking we did problems like this. Yes, we did. All right, let's just do a little chart. We could do a chart. How many, okay, let's do 45 out of 200. Let's just do percentages. Liked country. 67 out of 160 liked hip hop. The third survey, 16 out of 65 preferred rap. If the recording company were to choose 2 acts to perform, which combination would likely draw the greatest number of attendees? Okay. Let's put these into decimal form, please. 45 out of 100, that should be 22.5%. Now, guys, I'm not a wizard. I just cut this in half. All right. 67 divided by 160. I don't know. Good. 41.9%. Okay. And then 16 out of 65 is, got it. All right. Now, it says, if the record company were to choose 2 acts to perform, which combination would give you the greatest number of attendees? Well, which one are you going to pick? The one that has the higher percentages, right? Okay, so which was the second one? I forget. That's hip hop. And the last one was rap. All right, hip hop and rap. Okay, just see if I can squeeze this in. Oh. We'll look in the key, or I'll just record it after here because I feel like I'm going to have to say too much before the bell rings. Error analysis. The survey asked 40 people where they learned about their current events. What's the probability that a person gets the news by TV, given that the person is a male? Okay, so if the person has to be a male, there are how many males in all? So we'd have to add these up, and that is 20. Okay, now there are 20 females as well. 8. Oh, it said 40 people. There's 20 of each, actually. All right, so if we looked at probability of the person gets the news from TV, given that the person is a male, it would be 6 out of 20. Well, this person did 6 out of 40 and then reduced. She calculated the probability of a male TV for a male out of all. What is the correct calculation? Well, that's what we did up here. Probability of TV given that you're a male would be 6 out of 20, which is 3 in 10. Good luck on your finals. There's also PDF posted for both the big ginormous review and this one.